Okay, let's dive into a piece of tech that promised to be a total game changer for our gardens and farms. Drip irrigation. I mean, on the surface, it looks like the absolute perfect solution for a world that's getting thirstier, right? But as we're about to find out, what seems simple is anything but.
It all starts with this really powerful, simple idea. You've got this little tube with these perfectly engineered holes, and it's designed to get water right to a plant's roots, one single drop at a time. No waste, no water just evaporating into the air. Just super efficient watering.
And that's the promise that gets everyone so excited, isn't it? In a world where water is becoming more and more precious, drip irrigation really feels like the answer. But the real question is, how does this beautiful, elegant vision actually hold up when it smacks into the messy reality of our farms and our own backyards?
Well, to figure that out, let's start with the big picture, commercial agriculture, because this is where drip irrigation really seems to flex its muscles, and where the data, well, it tells a pretty amazing story.
So just take a look at these numbers from a survey of U.S. farms. It's pretty wild. A full 68% of farms said they got better yields and higher quality crops. 57% slashed their energy costs. And get this, 54% used way less water. For these huge operations, switching to something like drip isn't just a nice idea. It's a massive win, both for their wallets and for the environment.
And right here, this is where our story takes a sharp turn. Because if this technology is so incredibly successful on a giant scale, why do so many of us who try it at home end up wanting to tear our hair out? That promise of simplicity just seems to vanish into total confusion.
To really get to the bottom of this, we're going to put on our detective hats and dig into a real-world mystery that was posted on Reddit. It's a perfect example of one of those hidden tripwires that can completely derail a project if you don't know it's there.
Okay, so here's the scene. A user, Livius1, sets up 200 feet of tubing with a pressure regulator, but they only hook up 2 little emitters for a single tree. They turn the water on, the system fills up, feels firm with pressure, and nothing, not one drop.
And this is the part that is so baffling. It's not a clog. If you pop an emitter off, water gushes out, but the second you plug it back in, the flow just stops dead. It feels like it makes no sense. The pressure is there, but the emitters are just refusing to do their job. The user started to think, maybe it has something to do with the type of emitter they're using. And you were absolutely on the right track. The key to this whole mystery is this clever little gadget, the pressure compensating emitter, or PC emitter. It's designed to be smart. It has a little diaphragm inside that makes sure you get a nice steady drip whether you're at the beginning of the line or 200 feet away. But that smart design comes with a catch.
And the solution, hiding right there in the Reddit thread, is completely backwards from what you'd expect. The problem wasn't the pressure. In fact, it had nothing to do with pressure. It was all about a lack of flow.
Here's the deal. The pressure regulator itself, the very thing that's supposed to control the pressure, actually needs a minimum amount of water flowing through it just to work properly. With only 2 tiny emitters, the system just wasn't pulling enough water through. It didn't create enough of a load, so the regulator couldn't regulate, the pressure spiked way too high, and those smart emitters did exactly what they're designed to do in that situation. They shut down completely. Mystery solved.
But you know, these mechanical puzzles are really only half the story. The rabbit hole goes way deeper. There's a much slower, almost invisible process happening in the soil every single time you use a drip system. And this one is all about chemistry. Have you ever seen this before? These white crusty lines in a field? That's salt. See, all water, even the fresh stuff from your tap, has salts dissolved in it. Sprinklers tend to spread that salt out pretty evenly. But drip irrigation, it creates this tiny, super wet zone. And as that water evaporates, it leaves all the salt behind in one highly concentrated spot.
And this diagram just shows it perfectly. On the left, during the dry season, you can see that salt building up right at the edge of the watered area, which is exactly where a plant is trying to grow its roots. But then on the right, you see what a good solid rain does. It just flushes those salts down and away, essentially cleaning out the root zone.
Now, during the growing season, it gets even crazy. Research from California shows that subsurface drip creates these onion-like layers of salt in the soil. Right next to the drip tape, the water's fresh, salinity is low, everything's great. But just a few inches away, the salt concentration goes through the roof, creating these invisible walls that can literally stop a plant's roots from absorbing water. The plant is surrounded by water that it just can't drink. How wild is that?
So on top of the tricky physics and the invisible chemistry, there's just a whole list of plain old practical day-to-day headaches that anyone who's ever dealt with these systems knows all too well.
For starters, the tubing itself can be an eyesore. So what do? We bury it, which means you don't spot a clog until a plant is already dying. And that black tubing, it soaks up the sun, and the water inside can get dangerously hot, blasting a plant's roots when a system kicks on. And of course, it's just begging to be chopped up by a lawnmower, a shovel, or even chewed on by a curious dog or a gopher. But this might be the biggest, most ironic problem of them all. The very thing that makes drip irrigation work, giving a plant a slow, steady IV drip of water in one tiny spot, actually discourages it from growing a deep, extensive root system. It creates a lazy, dependent plant, which is the exact opposite of what we want in the long run. A strong, resilient plant that can actually handle a drought. So after hearing all that, you might be thinking, is drip irrigation just a bad idea? And the answer is no, not at all. The problem isn't the technology. It's the huge gap between our expectation of a simple little gadget and the complex reality of a living system. The key isn't to give up on it, is to get smarter about how we use it.
We go in expecting a set it and forget it system, but the reality is, you've got to watch it like a hawk. We think it's all about saving water, but we have to actively manage things like salt buildup. We think it's a simple plug-and-play fix, when it actually requires you to know a surprising amount about water pressure, flow rates, and even soil science.
Ultimately, getting drip irrigation rate all comes down to knowledge. You have to know your home's water pressure and its flow rate. You have to know your soil and how water moves through it. You've got to match your emitters to your system's total load, just like our Reddit detective figured out. And most importantly, you have to just pay attention. Watch your system, watch your plants, and really understand what's happening both above and below the ground.
You know, drip irrigation isn't just about watering plants. It's kind of a perfect metaphor. It's a reminder that sometimes the most elegant solutions aren't powerful because they're simple, but because they brilliantly manage a huge hidden complexity. And it really makes you wonder, doesn't it? What other simple things in our lives are we completely misunderstanding?